the bat again. But you didn't know this. It actually straps to my wrist. Woo! Isn't that cool? It's a bat that hangs on. Yeah. It's like one of those slap wrist things with the metal, but it's nice and cool. Because I went to where Dracula was written, Bram Stoker's Dracula, as well as the movie Whitby, and he turns into a vampire at night. Whoa, there's the bat! Okay, thanks for being here, finishing off our video for the practice test, is where we finished up yesterday. So we're either using the law of sines or law of cosines. If it's law of sines, if it's angle, angle, side, or angle, side, angle, if you have a couple angles. Or equal sides. So it could be side, side, angle, or side, angle, sides. No, side, angle, side is for law of cosines. So law of cosines is when you have side, 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 or side, angle, side. That's when you'd use the law of cosines. Cool. So they want us to solve the little triangle. Here we go. So we're just going to go ahead and draw a triangle with its sides. So go ahead and draw a triangle there. It's kind of a big triangle, Nibbled. Okay, a little smaller. Not that much room. Come on, Nibbled. So go ahead and draw your triangle there. Just label it A, B, C. Easy as 1, 2, 3. A, B, C. Baby, you and me, girl. Okay, so there's our A, B, C. Don't forget across from big A is little a. Label your triangle. Across from big B is little b. And across from big C is little c. So they give us that A is 35. That's kind of small. 35 degrees. They give us angle B is 70 degrees. And then they give us little c is 14 centimeters. Cool. So they want us to find all the sides and all the angles. Well, you can't really use the law of sines yet because you need an angle and a side, an angle and a side, or an angle and a side. But we're missing angles. There's no angle with a side anywhere. What do we do? Well, we could actually find that other angle, and we could find that other angle by using the other two angles. So how do we find angle C? So it's 180 minus 70 minus 35. And that's going to give us angle C. So 180 is what we're doing there. Whoa. So 180 minus 70 and then minus 35. Gives us 75 degrees. Nice. 75 degrees. There we go. So that's what angle C is. So we already found an answer. Woo! Found an answer. And we can also use that answer now. So C goes with C. And let's do the law of sines. And we're trying to find the missing sides. You have to choose A or B. You choose. Behind the screen. You choose. Go ahead. Say it. A or B. Which one? A? Really? Okay. Wait. Pause me. Try this next part on your own. You're only watching these videos to remember, double check to see if you do right. So try it on your own. Don't just copy me. You're going to fail the test. Don't fail the test. So try it on your own. So push pause like this. Pause me. Try it on your own. Okay, so we're going to try little a. So little a over, right? Let's use a different color. So little a over big A. So that's A, little a over. That's supposed to be an A. So little a over sine of the angle, big A, 35 degrees, is equal to, and now we can go ahead and use C with C. So the side length goes on top in this case, because we're trying to find the side length. Whatever you're trying to find goes on the top. And so we just found angle C, and that's 75 degrees. Right? Cool. So that's the setup. We have A over sine A equals C over sine of C is what we're doing there. Cool. So that's the setup. Now solve for A. That's easy. We're just going to have to solve for A. So we're going to multiply sine 35 over to the other side. So you don't make a mistake. Go ahead and multiply to the other side. And go ahead and put the 14 in front. So put the number in front and then the sign of the angle, just to make it easier. So now that's it. What's little a? So we go 14 sine 35, close parenthesis, divided by sine 75. Way-o. And so that's going to be 8.31. So we get little a is equal to 8.31, which in this case will be 8.3 because we round to the nearest tenth. So that's our answer for, oh, Mr. Newbold, now that we have A and C, can I just do the Pythagorean theorem?
No, it's not a right triangle. It's a non-right triangle. There's no 90 degrees, so no Pythagorean theorem. Right? On the wrist. Ow.
Don't do it. So Pythagorean theorem, don't do it. We have to use the law of sines one more time. So now we're going to go ahead and do B with B. So we're going to go and do little b and big B.
See how I circled the side leg with its angle? Do that. That'll help you.
So now we're going to do little b over sine of big B, 70 degrees, is equal to, let's just use what that gave us, or what we found originally. That's the 14 again, over the sine 75, just like we did before. And now you're going to multiply the sine 70, put it on the other side of 14, put it on the other side. Don't just do 70, you do sine of 70. And now that's going to give us little b, way-o. So that's 14 sine of 70, close parenthesis, divided by sine of 70. And that's using the law of sines. We get 14. Really? Oh, I made a mistake. Sorry. That's supposed to be what in the bottom? 75, not 70. Careful, Newbold.
Careful, Newbold.
Okay, we get 13.61. So little b is equal to 13.61 or just 13.6. So that's our little a and our little b that we just found, as well as angle C that we just found. So those are the three bits of information that we needed to do this problem. There's our three answers. Do you know how to do side, side, side? So to do side, 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 you have to use the law of cosines first. So this is side, side, side. So first you're going to use, law of cosines. And you can use it again to be careful, to be sure. Ooh. So first use law of cosines. Maybe second use law of sines. But yeah, it might be okay to do that. I don't know, this seems really big there. It's like tripled. Ooh. But it is side, side, side. So first use law of cosines, then use law of sines, and then third do 180 minus the two other angles, the measure of the other two angles. Use the other two angles. Cool. But also side, 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 we have to solve for the largest angle first. Otherwise, like in this problem, you could get it wrong. Because big C is triple. So this is little c is triple B. So that means this has to be obtuse. So don't do any acute triangle by accident. So solve for the largest angle first is what we want to do there. Cool. Okay, so let's do it.
Let's do it.
So we're going to draw our triangle, boop, 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 if it lets us. So we're going to draw our triangle there. We have little a, little b, little c. No, big A, big B, little c. We have little c is 9. That's going to be obtuse, Newbold. You should just draw it obtuse. Okay. So we'll draw an obtuse triangle there. It's going to be obtuse because 9 is triple the 3. Okay, so we're going to draw an obtuse angle there. We'll call that big C, which across from that is 9 feet. And then it doesn't matter the other two, angle A, little a, is 8. And then little b is across from big B, which is 3. So we need to solve for C, solve for the largest angle first. Okay, so we're going to do cosine then of big C is what we're going to do. And then we start with little c squared. And little c is 9 feet equals the other two sides, squared and added, minus 2 times those two sides. And this is where we're going to
Chunk it.
Now we're going to chunk it piece by piece to solve for angle C. So 9 squared is 81. We're going to do this first. This gets bracketed, so don't mess with that yet. So 3 squared is 9, 8 squared is 64. Add those together, what do we get? We get 73. 64 plus 9 is 73. We're going to minus that 73 over to the other side. Let's just make sure there. So 9 plus 64 is 73. We're going to take 81 and minus the 73. We get 8. Cool. So that's this side done. This side is done now. And then we're going to multiply this next. Remember, we got to chunk it. We got to chunk it. So that's a negative 2 times 3 is negative 6. Times 8 is negative 48. Times, there's a times there, times cosine C. Yeah, cannot combine this, cannot combine those, we have to chunk it. We have to chunk it with brackets, chunk it one at a time. Okay, so the reason why is because now we have to divide the negative 48 over to the other side. There it is, there it is. So that's going to be equals whatever's left, which is the, bring it down, the cosine C. And now, how do we undo cosine? To the other side, we're going to inverse cosine. And if you do it to one side, you have to do it to the other side. Way-o. So now we're going to go, make sure our mode is in degrees. So we're going to go seconds cosine 8 divided by negative 48, close parenthesis, and that gives us 99.59 or 99.6. So angle C is equal to 99.6 degrees, which is bigger than 90, which is an obtuse angle. Cool. So now we can, now that we did the use the law of cosines, now second we can use the law of sines now. And so to do the law of sines, I'm going to erase this over here so I have room. The law of sines now. And so now we're going to do our C with our C. And we're going to solve for, let's just do angle B. A next. You have to choose. You choose. So I chose angle A. So we're going to go sine of A over its opposite side, which is this guy, which is 8. Sorry, that's supposed to say equals 8. Equals C over C. And so that's sine of 99.6 over little c, which is 9 feet. 9 feet. Cool. So now I have to solve for A. So we're going to multiply by 8 over to this side like that. And then we're going to inverse sine. Remember that? You're going to inverse sine this whole thing. And that's going to give us what A equals. So plug that into your calculator now. So we're going to go inverse sine 8 times sine 99.6, close parenthesis, divided by 9, close parenthesis. And that gives us 61.2 degrees. So angle A is 61.2 degrees. That's our next angle. So far we have A, we also have C, which is 99.6 degrees. And now we're going to go ahead and find, if I can find it, or did I just have, oh, there it is. Cool. There it is. Just making sure we got this right for you. Okay, straw number 19. Cool, yep, we're doing it right. I just wanted to make sure there. Maybe angle A, 61.2, and 9.6, yep. So last but not least, is going to be the third thing now, which is 180 minus the 2. 180 minus the 2 angles is what we do now. So now we go 180 minus those 2 angles, so minus 61.2 and also minus 99.6. Or you can add them together and then minus it, up to you. So 180 minus 61.2 as well as minusing 99.6 will give us our last angle, 19.2. So angle B is equal to 19.2 degrees. And that is our third angle. We found it. That is our third angle. We found it. Nice. So again, C was 99.6. A was 61.2 degrees. And B was 19.2 degrees. We did it. Side, side, side. It was tricky. But we did it. So now we need to do the side angle side for number 20. And then number 21 is angle side. And that's pretty easy. Just use law of sines. Just use law of sines a few times, like twice. There-o. Yeah, so that was not too bad. But this one is definitely tricky because this is a side angle side. So we have to use the law of sines now, right? Because that's a side angle side. So we go ahead and draw our 42 degrees. And so across from big C is little c, which we don't know. And then we have big A, we don't know. We do know little a is 11 inches. And little b, so this is big B, across from big B is little b, which is 17 inches. And so side angle side, we're going to have to use the law of sines to find, you have to find little c first, then you can use law of sines. So that was for, no, not law of sines. Sorry, this is SAS. And side angle side is, sorry, it's law of cosines, right? Law of cosines. Then law of sines. Cool. So first we have to do the law of cosines first. Law of cosines first. Okay, so here it is. We solve for little c. So little c is c squared is equal to a squared plus b squared, the other two sides. And then minus 2 times those sides. And then times cosine of that angle we have, big C. So little c we don't know. We're still trying to solve for it. A squared is 11 squared plus b squared is 17 squared minus 2 times 11 times 17. And then cosine of angle C was 42 degrees. And now you can just plug this whole thing into your calculator. Just plug it all in to your calculator and then square root it. So we're going to go 11 squared plus 17 squared minus 2 times 11 times 17 times cosine of 42 degrees. And that gives us a huge number, 132.063. So 132.063. And then you have to square root it to get little c. You have to square root that. And so that's going to give us little c, using a lot of cosines, but doing it the easy way, not having to solve for a missing angle or anything. There we go, beautiful. Sweet 11.49. So 11.49, which rounds up to approximately, we'll say 11.5. So can we use the Pythagorean theorem now? No. Can't use the Pythagorean theorem, no. But we can use now the law of sines. And then we can solve for a missing angle. Let's try angle A now. So now we can go ahead and do sine of A over little a, which is 11. Pause me, try it on your own. You pause me, try it on your own. then we have sine of c, which is 42 degrees, over little c, which is 11.5. We just found. Let me make sure. Yep. Okay, so then we're going to go and multiply by 11 over to the other side like that. And then we're going to inverse sine. And if you do it on one side to solve for a, you have to inverse on the whole other side. So that's basically the inverse of 11 sine. We multiply 11 to the other side, all over 11.5. So go ahead and plug that into your calculator now. So you're going to go inverse sine of, pause me. Try it on your own, practice. Try it on your own, pause me, and see if you get it right. Here we go. Okay, inverse sine of all that gives you our missing angle A, 39.79. So A is equal to 39.79. That rounds up to what, 39.8? So that's going to be angle A, which is 39.8 degrees. We also found C, and now we just need to find B. So to find B, we can actually do 180. Minus the 42 and minus the 39.8. And so when we do that, uh-oh, did I do something wrong? I feel like I might have done something wrong. You have to use law of cosines twice? Uh-oh. This could be bad. We'll see. Could be bad. No, I'm getting the same answer. So 180 minus 42, and then minus 39.8 gives us 98.2 degrees, which is an obtuse triangle. So that's 98.2 degrees, which is an obtuse triangle. I don't know, that seems to work okay. So we get 98.2 degrees for angle B. Yeah, so I think that'll work, but I'm going to double check the law of cosines really quick. So if I was going to find angle A using law of cosines, I would have to do little a squared minus the other two sides, which we just found, squared and added. So that'd be 11.5 squared. What's the other side? 17. This is finding A right now. So that would be this number. And then we would divide by the other thing, minus 2 times those sides. So minus 2 times 11.5 times 17. And then we would inverse cosine that. So that's our answer. And so that should give us 39.8. So Mr. Newbold did it right. And I don't know if Lucarini did that right. We'll have to question his number 20. Okay, beautiful. So those are our 3 answers there. And then use law of cosines there. Use law of cosines. So now we're on the back side where we're going to use the area now. We're going to find the area of each triangle. And so we have a formula for side, side, side if you want to use it. There's actually a different formula for the area. Up to you if you want to use it. So it's S is equal to A plus B plus C divided by 2. So S is equal to 2.5 plus 10.2 plus 9, all divided by 2. And then after you do that, we're going to plug into this formula for the area. This is called Heron's area of a non-right triangle formula, basically. A non-right triangle formula. It only works with side, side, side. Only works with side, side, side. Okay, so that's going to be the square root of that S, whatever we find right here, times S minus each of those sides. So that's S minus A times S minus B times S minus C. So let's give that a try. So we're going to go ahead and do our 3 things there. 2.5 plus 10.2 plus 9. So we add our 3 sides just like that. And then we divide that by 2. We get 10.85. That's messy, but oh well. So we get 10.85. And now we plug that into our formula and each of these into our formula. Right? We plug each of those numbers in, and we also plug in all the s's. Yeah, this is a weird way to do it, but let's give it a try. So area equals, it's just mostly calculator now. Okay, here we go. We're going to do the square root of that 10.85 times 10.85 minus 2.5 times, 10.85 minus the next number, which is 10.2, times 10.85 minus the last one, which is 9. And we get 10.437, which is just 10.4. So 10.4 inches squared is our answer. You can use the other one, which I'll show you here in a second. There we go. Yep, 10.4 inches squared. Cool. Let's use the other weird formula. Cool. Or you can find using law of cosines first. And then this one is already side angle side. Right? If you draw this triangle, ABC, so A is 36 degrees. Across from that is little c, which is 23. And then across from big B is little b, which is 35. So we already have side angle side. Side angle side. So we can use the other formula. If you have side angle side area formula, which is 1/2 times the side times the other side times sine of the angle. Now that angle has to be in between the sides. It's got to be side angle side. It's got to be side angle side. Okay, so here it is. 1/2 times 35 times 23 times sine of 36. So you're just going to plug that in your calculator. So the area equals, there we go. So 1/2 of 0.5 times 35 times 23 times sine of 36 degrees. Wait. So 236.6 feet. So 236.6 feet squared is our answer. Woo! Good job. Man, we're on 20 minutes, so I guess I'll have to stop now. Thanks for watching. Watch the last video for the review that's going to be on the test. Whoa, don't forget the review. And don't forget the sine and cosine. Grab me. Okay, thanks for watching. Bye for now.